So rationals is the unit that deals with how to do math with fractions. And we're going to warm up with just number fractions, but obviously we're going to get into complicated fractions that have variables in them. Okay, so let's get some rules here. In fractions, what happens to a fraction if you have the same thing divided by the same thing? What would the rule always be?
Cancels.
Cancels, which makes, what does a cancel make? 1. Okay, sometimes I get people who cancel it and then they write 0. That's not what it is. A cancel would make 1. What happens if the numerator is 0? It's 0. What happens if the denominator is 0? Undefined. You remembered the word. You can't define the math number that divides by 0. Okay, what do you do when you add or subtract fractions? What's the big idea? What do you need? You need the denominators the same. So this one has a 2 and this one has a 4. What do you want to make them? I'm going to want them both to be a 4. So I'm going to cross this 2 out and change it to a 4. But if I did that, what would the top also do? Times by 2. So this would be 5/4. Remember how to do that? Okay, we'll skip. Let's do this one. So we just talked about that word common denominator. So what do I want the denominator to be? What am I picking? 35. Okay, so if I make it a 35, what would I have to do to this one? Times by 5, so now it's a 30. What would you have to do to the second fraction? Times by 7, so minus 14. Okay, timesing fractions. So timesing, I could just go 6 times 14 on the top, 7 times 18 on the bottom. But in this unit, you're going to need to reduce everything fully. So I'm going to try to reduce before I times. So what could I possibly divide the top and the bottom both by? I could divide them both by 2, that is true, but there's more. What's a bigger number I could divide both the top and bottom at least by? 3, I could do that as well. That's still, I could do more.
4.
I don't really want to divide 6 by 4 or 14 by 4. Anything else? You're getting closer. You keep going up in your numbers.
6.
6, I like 6. Okay, let's say if I divide the top and bottom both by 6. Here's what I'm going to do. The 6 would turn into a 1, and the 18 would turn into a 3. Okay, now I'm going to do that process again. What else could I divide out? 7. Let's say I'm dividing by 7. I'm going to cross out the 14 and make a 2, cross off the 7 and put a 1. So what is my final answer? So 1 times 2 on the top is 2. 1 times 3 on the bottom is 3. I know.
That it is, Dad. That it is.
Snowing sideways.
Wear your lucky penny on the floor.
Okay, let's try this one. What do you do when you
think I had it yesterday.
Divide fractions.
I'm not strict of me on this chair. It's almost not my best friend. Also my best
I know what you mean, but that's okay. So I often hear, hey, let's cross multiply. Okay, cross multiplication is when you do something over an equal sign. So we're going to change the process of dividing into timesing and flipping. So 24 over 5 stays, and instead of dividing by that fraction, you times by its reciprocal. Okay?
It doesn't switch to a negative.
No. You're thinking of perpendicular slopes.
Oh, right.
Okay, now we're going to do what we just did. What am I going to divide the top and the bottom both by? Something. What do you want to pick? We can do a couple things. I'm going to do a 5 first. Is that okay? If I do a 5, cross off 1, cross off 2. Now, somewhere, what else do I want to divide the top and the bottom both by? 2. So if I do a top 2, this can change to a 1, and this can change to a 1. And I get 24.
Whoa, that was crazy.
Because I crossed everything off. Everything was a 1 except for that. Okay, let's do this one. Okay, bed mass. Bed mass. What do you want to do? Multiply the first. Okay, what do you want to, just looking at that, what can we divide the top and the bottom both by? 7. I like 7. So if I divide some kind of number on the top by 7, so 14 divided by 7 is 2, 7 divided by 7 is 1. Then I'm still going to reduce.
3 and 15.
3 and 15 are both divisible by 3. So that's going to be a 1, and that's going to be a 5. Okay, so all of that reduced to 2/5. Now I'm going to do the subtract because the bed mass, I had to do the multiply. Now I'm going to do the subtract. So I would need a common denominator. So what is the denominator number to pick here? 10. So 9 stays put. And this would times by 2. So 9 minus 4 is 5/10, which is now 1/2. So all that came out to 1/2. And we didn't even touch our calculator to do it. Hopefully you didn't. Okay. So this is all old stuff. When did you learn that? Grade 7, 8? I don't remember. 9? You've seen fractions before that.
Oh, right.
Common denominators, things like that. Okay, mixed to improper. You've probably seen that somewhere. Junior high. Okay, if I have this, it means that when I cut my pie, I'm cutting it into 9 slices. So let's say I ate 2 entire pies of 9 slices. How many have I eaten right now? 18. And then 2 more slices. So 29ths. Okay, this time I'm cutting my pies into thirds. And I ate 17 slices. So how many whole pies?
5.
There's 5 whole pies. So if I ate 5 entire pies with 3 slices, that's up to 15. So 17 means there was 2 more.